Hi there, this question is from the 2016 exam 1. It is from the geometry and trigonometry section and it is question 8. So a string of 7 flags consisting of equilateral triangles in 2 sizes is hanging at the end of the racetrack as shown by the diagram. The edge of the length of each black flag is twice the length of the edge of each white flag. For this string of 7 flags, the total area of the black flags would be, and we've got our responses there. So this one, we're actually looking at how much bigger the black flag area is than the white area. With this question, the first thing that comes to mind is we have not been given any actual numerical values for how big these triangles are, except from that one length is twice as big as the other. So let's have a look at this and let's draw out the two. So we have ourselves the white flag, and then we also have ourselves the black flag. Give that a bit of a shade. So from the question, it did say that the edge length of the black flag is twice the length of the white flag. So if this was a 1, this must be a 2. So in terms of k factor, if we're scaling this, our k would equal 2. Because the black flag is the length is twice as big as the white flag. So we've got a k factor now, so hopefully we can do something along the lines with this. So what we can do is talking about the area, so let's estimate a value for the area. So if we're going to say that the white flag, here, I'll draw it a little bit bigger, has an area of 10 centimeters squared, we can work out the value of what the black flag will be by using the k value and doing the appropriate calculation, knowing that we're calculating with area and scale factor, so it's going to have a square on the k factor. So let's do that. So the area of the black area of the flag is the white area times by our k value, and as I said, because we're using area, we need to square this value. So the black area of the flag would be equal to 40 centimeters squared if the area of the white flag was 10 centimeters squared. From the question we can see that we have 4 black flags and we also have 3 white flags. Okay, so let's work out the area of the black flag. So if we worked out that the area was 40, we would have 4 by 40, which would be 160 centimeters squared. And we also have if we represent that we've got the white flags, we've got 3 of those, and we started with the value of 10 centimeters squared, which would be 30 centimeters squared. So what we're doing now is comparing these 2 areas, so the area of the black flag and the area of the white flag. And we can compare that to find out how much bigger the black one is by seeing how many times the white flag area can go into the black flag. So a simple calculation, 160 divided by 30 equals 5.3 reoccurring. And if you're using your scientific calculator, you can press the fraction button. If you're using your CAS calculator, you can also press the change from decimal to fraction. And 5.3 reoccurring does equal a fraction of 16 over 3. So the area of the black flag is 16 over 3 times larger than the white flag. So if we have a look at all our responses here, we can see that straight there, 16 over 3 times the area of the white flag is the answer, so D. Having a look at our assessor's comments, we are doing question 8. Only 30% of the cohort could identify that D was the correct answer. So quite a large sum, I believe, would have guessed this question. One being that it was the last question in the module and people were either running out of time or that they weren't quite sure and they just guessed it. But this question does require you to use your k factor, and if in any question they don't actually give you a value, you can always substitute your own value like we did at the start. We just gave the area of the white flag as 10 centimeters squared and we ended up getting to the correct answer. Hopefully this one helped you.